Hey everyone, we are going to deep into four important concepts in operating systems: multitasking, multiprocessing, multithreading, and multiprogramming. First is multitasking. Definition: the ability of an operating system to run multiple task processes simultaneously by rapidly switching the CPU among them. How it works: only one CPU core executes one task at a time, but by switching very fast, it appears that tasks run concurrently. Example: running a browser, music player, text editor together on your PC. See, multitasking is the ability of an operating system to run multiple tasks or programs at the same time. Okay, but most computers have a single CPU core. Most computers have a single CPU core which can execute only one instruction at a time. Okay, most computers have a single CPU core which can execute only one instruction at a time. So, how does it handle multiple programs? See, through a process called context switching. The CPU rapidly switches between the different tasks, giving each a small time slice. Okay, the switching is so fast, so our eyes it looks like all programs are running simultaneously. Okay, for example, when you are browsing the internet while mm, listening to music and downloading a file, your CPU is uh, juggling between all these tasks very quickly to give you a smooth experience. Okay, next is multiprocessing. Definition: using two or more CPUs or cores in a system to execute multiple processes at the same time genuinely in parallel. How it works: each CPU core runs a different process simultaneously without switching. Example: a computer with four cores running four processes at once. See, multiprocessing takes this idea further. It involves having multiple CPUs or cores inside a single computer. Imagine a core processor. It has a four independent processing units. Okay, each CPU core can handle a different process at the exact same time, parallelizing the workload. This means multiprocessing provides a real simultaneous execution of multiple processes. Okay, means multiprocessing provides real simultaneous execution of multiple processes, increasing efficiency and performance. Okay, for tasks that can run independently. Okay, third is multi-threading. Definition: a single process is divided into multiple threads that can run independently but shares the same memory space. How it works: threads within the same process can run concurrently, improving resource sharing and responsiveness. Threads can run on multiple core or be time sliced on one core. Example: a web browser rendering page content on one thread and running JavaScript on another. See, uh, multi-threading which happens inside a single process. A process can be thought of as a program in execution. Okay, and multi-threading divides this process into multiple smaller threads that share the same memory space. uh, these all threads run independently but can communicate easily since they share data. They can run concurrently on multiple CPU cores. See, they can also run concurrently on multiple CPU cores or mm, switch rapidly on single core. See, a web browser uses multi-threading by rendering a web page on one thread, okay, and then running JavaScript on another, and handling user input on another, all working seamlessly together. Then fourth is multiprogramming. Definition: loading multiple programs into memory so the CPU can switch between them to maximize utilization. It's an older concept focused on keeping the CPU busy by organizing jobs in memory. How it works: only one job runs at a time, but the CPU switches between programs when one is waiting, like for IO, so CPU stays busy. Example: batch processing systems where jobs are loaded and executed by one with minimal idle CPU time. See, multi-programming means an older but foundational concept. Okay, multi-programming involves loading multiple programs into memory. Okay, multi-programming involves loading multiple programs into memory so that CPU always has something to execute. Okay, when one program is waiting for input output operations, the CPU switches to another program instead of sitting idle state. Okay, when one program is waiting for input and output operations, the CPU switches to another program instead of sitting idle. The primary goal here is to maximize CPU utilization by keeping it busy as much as possible. Okay, this technique was widely used in early batch processing systems where several jobs were prepared in advance and run one after another with minimal idle CPU time. Okay, see, multitasking and multiprogramming are about efficient time sharing on a single CPU. Okay, multitasking and multiprogramming are about efficient time sharing on a single CPU, with multitasking focusing on running multiple tasks simultaneously by rapid switching, and multiprogramming uh, focusing on keeping the CPU busy by managing multiple programs in memory. Okay, and multiprocessing leverage multiple CPU cores to execute processes truly in parallel. Okay, and while multi-threading breaks down a single process into multiple threads. Okay, multi-threading breaks down a single processor into multiple threads for better resource utilization and responsiveness. Thank you.